这期会员节目是4月底我在旧金山主持了一个关于生成式 AI 的活动。这期活动我们邀请到了硅谷徐老师 Howie， 邀请到了贾扬青，邀请到了 Martian 的 Founding Engineer Jason，OpusClip 的 CTO 和 Cofounder Jay。徐老师和贾扬青大家都应该很熟悉了。Martian 是一个 Large Language Model Router， 它会根据你的任务自动的帮你选择最适合处理这个任务的 Large Language Model， 无论是从性能、速度还是成本上。OpusClip 应该是整个生成式 AI 界当红炸子鸡的创业公司之一。它是一个把长视频变成短视频的这样一个 App， 大概花了6个月的时间就把营收做到了1500万美元。如果大家对创业有所了解的话，就知道这是一个非常奇迹般的数字。所以说我们这次嘉宾的深度是非常之深的，他们的经验来自于投资，来自于过去很长时间的积累，更来自于一线的实践。具体的嘉宾介绍和我问的问题我就放在这个视频的 description 里边，大家欢迎去看。我简单说5个我总结的亮点。第一个是嘉宾们对生成式 AI应用成本的思考，就是它到底是一个超线性增长呢，线性增长，还是一个低于线性增长。大家都知道，如果你的成本是超线性增长的话，你是不可持续的。如果你是线性增长的话，基本上你都是在为 OpenAI 打工。如果你是这个低于线性增长的话才可以。那嘉宾们就分享了很多他们一线的实践，这里边不光是来自于你在用量上去了以后你可以谈的各种各样的 deal， 其实这反而是你成本优化的一个小部分。更重要的是来自于你整个环节的优化，以及杨青提了一个非常重要的观点，就是 supply chain 是有这样的一个理论的，就是你的成本的优化会 reward planning， 就是当你的需求越确定的时候，你的成本就越低。你遵循这一条第一性原理的话，你就会发现随着 GenAI 应用的成熟，你在工程上和在供应链管理上就有很大的降本空间。第二个就是生成式 AI 和过去的软件工程其实是有一个 fundamental difference 的，那就是它是一个 fuzzy in fuzzy out， 杨青说的是 sloppy in sloppy out， 就是它有很强的不确定性，但是这个不确定性也导致我们可以做很多之前的软件所做不到的事情。所以说怎么样子去应用这一点是一个很具有挑战但是有很有机会的一个领域。具体嘉宾在视频里面有说，想了解的话就直接去看视频就好了。第三个就是它会是一个 centralized 还是 decentralized， 那这里主要是 Howie 的理论，大家也表示赞同，就是它其实会是一个钟摆。你如果去看整个 computing history 的话，它也是一个钟摆，它会在这个钟摆下不断前进。第四个，想要去做好生成式 AI 的应用，现在最需要被解决的环节之一就是 evaluation， 这也说了他们的经验，就是他们如何用 AI 去 evaluate 其他 AI 的，也是一个非常有意思的技术方案。然后大家的总结就是，其实你无论是做生成式 AI 的应用还是做其他应用，你的 domain knowledge 最后才是你的护城河。那你对 domain knowledge 的理解就能让你能更好的去 evaluate AI， 从而放大 AI 的效果。最后一个呢，就是在整个对话中不断的提出来，尤其是杨青会不断的 remind 我们，其实我们现在看似遇到的新问题都是有old solution 的，包括如何用一个概率的方法去解决分布式系统的不确定性。可是这些 old solution 是需要大家去做的，所以说大家与其坐在这里抱怨 GenAI 有什么 hallucination 的问题，或者说没有办法和我以前的这个生态很好的结合，其实更多的这些是机会，这些是需要大家去解决的。这里插播一下，我跟鸭哥的那个 Maven's Course其实讲的就是这一点，就是我们必须要有一个 builders mindset， 我们去解决问题，你才能抓住那些机会。你等着别人解决问题的话，你是抓不住那些机会的。这里就是我的小总结，任何一个总结对原文都是有很强的信息压缩和信息损失的，所以说我非常建议大家直接去听嘉宾到底是怎么说的。还有一个抱歉的点，就是我只有前10几分钟录上了，后面我的机器过热没有录上，但是我在主持就没有看到，所以说后面就只有声音没有画面。我们给大家会放一些活动现场的精美照片，但是确实就没有嘉宾这个聊天的对话画面了在这里向大家说一声抱歉。那我们就开始吧。
Hey everyone. Hi everyone. We're going to get started in just a minute or two here. So if you want to grab a drink or a snack and then find a seat. Sorry. We're going to get started in just a minute or two. If you want to find a drink or a snack and then find a seat, that would be awesome. Thank you.
哦，直接来了吗？啊，直接来了，直接来了，就按照这个来是吧？来就好。
Testing one.
Pointed to the yeah.
Testing two. Testing one.
All right. Hello. Let's try. I think it's good. Check. 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 Check.
Check, check. Can you hear me? Okay.
Could you
Testing
check that
one, two,
mic?
three.
Yeah.
Hello, hello.
Yeah. Nice. All right. Thank you, everyone. Welcome to AB Talk. And at the social hour, a lot of people ask me why AB Talks. It is because this event is sponsored by our company, Static. Static is a modern data platform for product development. And we offer essential tools such as feature gates, experimentation, and analytics. Static is hosting this event for the sake of the community. And also because we provide services to a lot of AI companies, such as OpenAI, Anthropic, and Character.ai. So we want to learn from the AI community about the best practices in product development in the GenAI era. So that is the house cleaning. Our team member, Morgan, is the event manager there. If you need anything, just go to Morgan. Jesse is our head of recruiting. We are 100% on site at Bellevue, but if you're interested, we have a lot of position open. And Brock, our dev relationship. Yeah. So if you need anything, just find one of us. Let me do a quick intro about our speakers tonight. We are honored to invite Howie, Yangqing, Jason, and Jay here. So I prepared a little bit introduction if you don't know them before. So first, Howie is a seasoned technology veteran in Silicon Valley with a career that began by founding VMware's network division, now a multi-billion-dollar revenue business. His diverse experience spans founding startups, holding executive positions at industry-leading companies, serving as an entrepreneur in residence at Greylock Partners, and mentoring and teaching at prestigious institutions such as Stanford University and leading B2B accelerator Alchemist. Howie has recently started a YouTube channel. It's called Byte into Future. Make sure to subscribe now, and he will host some amazing entrepreneurs and do live streaming from the iconic New York Stock Exchange floor in just 2 weeks. So Byte into Future. Make sure you subscribe. Next, I'm pleased to introduce Yangqing, the founder and CEO of Lepton.ai, one of the top performing generative AI infrastructure service platforms. Remarkably, using Lepton's infrastructure, Yangqing developed a large language model-based search engine with just 500 lines of code in less than a week, which he then open sourced. And I want to add, and sparked a debate with the CEO of Productionizing.ai.
A very friendly conversation.
Friendly conversation. You can check the Twitter thread. Prior to Lepton, Yangqing was a vice president at Alibaba. and the director of AI infrastructure at Facebook. There, he created Cafe 2.
Cafe 2. Cafe was actually back in the grad school days, back at Berkeley, across the bridge.
Oh, nice. And Onyx, among other things. And he co-led the development of PyTorch, which has become the most popular machine learning framework.
Yeah, actually, since we're already making advertisement with YouTube channels and hiring and things like that, we recently, well, we're an AI infra company, so people always wonder what AI infra companies do, and we made a really cute little Chrome extension called Elmo Chat. Elmo as Sesame Street Elmo. So if you go to elmo.chat, you can basically install it as Chrome extension. What it does is it summarizes every single web page for you, whether it be news articles, be Hacker News posts, Twitter discussions, YouTube videos, PDF, and things like that. So completely free. This is basically our way of basically introducing something that could be used by users and run completely on the Lepton platform. So if you're interested, just check it out. It's elmo.chat, and yeah, completely free, pretty high quality. And I apologize, my big stupid head covering the screen. Sorry.
No, it's perfect. And I actually was gonna plug in that in my first question, because the first question is about product, but great plugging.
Oh, thanks. Jump the gun.
And next one, we have Jason. Jason is the founding engineer at Martian. And Martian is a fast-growing LLM router launched last year. If you don't know what router is, Martian router is about selecting the best AI solution for your tasks, and is already adopted by developers from over 300 companies, including OpenAI and Amazon. Before Martian, Jason did research at Chicago Human Plus AI Lab and ByteDance. He leads one of the largest AI communities in the Bay Area, Alliance.ai, with speakers and communities members from OpenAI, NVIDIA, Stanford, and more.
Since we're also doing ads, everyone please follow our Alliance AI Twitter, ALIGNS.ai, and we constantly hold events in South Bay. So everyone's welcome.
Right. And the last one, I don't think you even need to do the ads because the introduction is about your product. Jay is the co-founder and CTO of OpusClip. His startup pivoted from a streaming tool to the current AI video clipping product in 2023 and launched in June that year. In less than a year, OpusClip is reaching 15 million annual recurring revenue and is growing fast. So if you are familiar with startups, you should know how crazy this growth is. I am a heavy user of OpusClip myself, and I just found out that Howie is also one, but I'm a paying member, and I think Howie is still on the free tier right now. Yeah.
No, paying user.
Oh, you already paid?
Because I started this YouTube channel. Speaking of commercial, make sure you subscribe, because that's also supporting the Opus as well.
Nice. Yeah. And before that, Jay was an engineer manager at Airbnb and engineer at LinkedIn with a broad spectrum of engineering practices. So that's all the introduction. As you can see, we invited speakers in the GenAI space, not only in the product, but also middleware and infra. So today, we hope to go to some deep questions. I prepare a list of questions, but even if we just cover one, but cover a lot of perspectives, I think it's still good. So I'll leave 20 minutes for audience Q&A as well. All right, so I'll just start. And the first question, I'll start with Jay. Is building GenAI products fundamentally different?
So, check. Is it working? Yeah. Okay. So yeah, there are definitely things that are different, and some things are. Yeah. Thanks. So some of the things are different. Some of the things stay the same. So let me talk about the things that doesn't change. So when you build a product, you still need to understand deeply what the user needs. So you can refer to these theorems such as jobs to be done. And of course, so also like things like design and marketing is still very important. When people talk about Gen AI applications, you might think that we need a line of input like Chat GPT, and you don't need the design. That's pretty much wrong, at least in my product. We still build a relatively good, beautiful product that is easy to use. And also, marketing is important. We had a growth that was pretty good because we built relationship with different influencers during the previous not so successful product. When we launched this product, people that we knew were so excited that they decided to talk about our product for free because it makes them cool and they really love the product. But if you don't know these people, you're not so ready about marketing, then you might be a follower. A similar product might just be a leader position in the market, and you may not have these free traffic. So of course there are things that are different. For example, user tolerance is typically higher compared to more incumbent spaces. People know that it's a AI product, and they know that it's very new, that the technical aspect could be different and challenging. So people are so excited that it gives them a lot of productivity, but at the same time, they are okay with some of the bugs. And also, cost can be a lot of a concern. So we started by having 5x more, even 10x more cost per processing power we provide to the user in the beginning. And we tried really hard to bring it down so that we can reach cash positive. Otherwise, we would just be working for OpenAI, basically. At the same time, I can see a lot of our competitors, they were not having the mass scale effect, which economy of scale, so they could be really suffer from higher cost. And in the long term, a much higher cost efficiency can be really important for your product. So something that is very different is prompt engineering becomes a thing, and it's quite new. It has some implications during your collaboration, because before you might have a bunch of research engineers. They are AI engineers, they train the model and they finish everything. But during the prompt engineering era, you probably don't need many hardcore AI engineers, but you need people who can write prompts. And these people could be product managers or product operation people. They need to work in joint with your AI engineer, so to write prompts, tune the prompts, and make things work. So that's pretty much, I think, answer from me.
Nice. We can do freestyle, or we can do a round, maybe clockwise. So, Howie?
Sure. I think it's very, very different from the last generation of the software, both on the enterprise software and then consumer software. Let me talk a little bit more on the enterprise software, which I know a lot. So if you think about enterprise software, preciseness, correctness is very important, right? And the predictability, reproducibility is very important. And then there's no reproducibility with GenAI application. Now, some use cases like text to SQL generating a table, generating the result, you cannot be wrong even 1 out of 1,000,000 times, let alone 1 out of 100 times, which is you're already pretty good if you are right 99 out of the 100 times. So you have to rethink about how do you do it, right? It's not the end of the world, because what you're going to do is actually you limit the input space, output space, and somehow figure out a way so that the result is actually a lot more predictable, way more than OpenAI APIs allow you to do. So you have to rethink about it. That's sort of on the just the software side design. And then we all know that a QA is another aspect, an important aspect of the software. And the QA thing is totally different. Like especially if this is text-based, like what is correct or what is not correct, who's going to label it for you, who's going to tell you this is correct. In the traditional software, you sort of do a happy path, and then you figure out some corner case, right? Extremely large number, extremely low number, 0, minus, whatever. So you kind of know that if this software is right for 5 and a 6 and 8, you know that if the input is 10 and 11, it's likely correct. But you need to figure out whether when it's 0, input is 0 or minus 1 or infinite large number, whether that's still correct. But in the generative AI, it's unclear to me. If I change, add 1 character, maybe the output is totally different for one reason or another, right? So it's a lot less predictable. So it actually adds. I think we as industry need to rethink about how to do even QA. What does that mean to do QA in the enterprise software? So I'm just giving you a few examples. So one of the reasons you see that there are not enough of the enterprise GenAI application being in production is because the kind of the issues I was talking about. In December 2023, there was an article from CNBC. You can search it. It's basically the title of the article is 2023 is a year that hefty profits for Nvidia, and then lofty experiments for the rest, which captured pretty accurately what was going on in 2023. I'm pretty sure that 2024 is going to be a lot, well, somewhat better. Whether it's a lot better or not, we'll see. And if you think about why it's sort of so many lofty experiments, but a lot less production, it has to do with the software nature is very different. So that's just that, right? And then of course, I'm not necessarily the expert in the consumer software. I think that there is something very similar in that it's a very different. Now for the consumer software, there's one thing that potentially you have an advantage is like the kind of things that Jay is doing, right? You generate, basically I give you a video, you generate some clips, but there's no correct answer, right? It could be 1.5 minutes, it could be 1 minute. So you have more leeway, to sort of make sure that customers or the clients or myself, I'm actually a customer, right? Even if you give me 1 minute or 1.5 minutes, that's fine, right? So you have some leeway. There's more tolerance. I think Jay mentioned it. But that doesn't mean that that does not mean the problem is much easier. For instance, right, just because I care a little bit less whether the end result should be 1.5 minutes and then 1 minute, but ultimately there's still a satisfaction, right? So if the 1.5 minute video always, below my expectation, it's still going to be it's still not, if that's the case, I wouldn't use the software, right? I feel like above my expectation, I use it. But how do you make sure your software is actually reach that above that threshold and then predictably get to that state? It's actually not easy. Your feedback loop is a little bit fuzzy in terms of what is correct and what is not correct. So overall, my feeling is the software is very, very different in generative AI, era than the previous generation.
Thank you. And one thing I pick up from the answer is seems like GenAI is a paradigm shift. And for a paradigm shift is fundamentally new, then maybe the old way of doing things cannot be just continued. You have to think about a new way, which we can deep dive in my question number 3. But before that,
yeah, I think Howie actually made a really good summarization already, but let me describe it in a mathematical way. I think it's going to be different, mainly because the way of interaction is different. In the old days, computer science is all about going from the sloppy input, our abstract needs and things like that, very quickly into a logical world, whether it be a piece of code, some sort of JSON, some sort of APIs, and things like that, right? We have very sloppy input and then very fixed output. And now suddenly this whole thing just changed. With ChatGPT, you find that this AI has become a black box and some sort of really sloppy random output, right? I mean, for human interaction, it's fine, but it just, like, how do you actually connect ChatGPT output to like a database query, right? So as a result, I think basically two things started emerging, which wasn't, wasn't some important stuff back in the days where we all work with APIs and computers talk to each other. One is basically we started building applications on top of the sloppy input, sloppy output kind of situation, right? There's all kinds of AIGC companies. There are chatbots. There are, even search becomes kind of sloppy because you just search for something that gives you an answer. It doesn't really give you fixed results or things like that, fixed pages. It just gives you a sloppy answer, which even isn't actually like completely correct. So that's basically user experience starts changing. We see quite a lot of really awesome product managers actually utilizing those kind of tools to create new experiences, new functionalities and things like that. Because our world, when we interact with this world, we are so comfortable with sloppiness. And that's basically one thing. The other thing, the second thing is basically we are starting, actually only starting, to basically solidify the old way, but using AI technology. We still want to go from a sloppy world, sloppy input, to a fixed logical world. Like code generation is one, right? You might have heard about, like say language to SQL, which is another one, and there's a lot of other examples. And that's why we see a lot of work starting to actually kind of put in shackles put in handcuffs on the large language models. We have JSON output, we have function call, and things like that. At the very bottom, we're defending the old model, which is a sloppy input and a fixed output, a fixed logical world, because that is still hugely important. So I think, like basically the first one is completely new sloppy input, sloppy output enabled by AIGC and LLMs. And the second one is basically since we want to take these kind of new technology into the existing work pipeline, then there's quite a lot of peripheral tools and functionality and things like that that needs to be done. I think these are the two different parts.
Nice. This reminds me of a podcast we did with Jason, and I used the word fuzzy input, fuzzy output. Is sloppy is the industry standard?
It's kind of equivalent, basically. Well, I made it up, so
nice,
it's not standard for sure.
Cool. Yeah, Jason.
Yeah, I think Yangqing's point is very, very interesting, and we're seeing different modalities in the like how LLM computation interact with traditional computation, right? On one hand, we have traditional software which is totally deterministic. We have JSON formatted output, which try to make LLMs more deterministic. We have something more like DSPy, which is a project led by Stanford NLP people, which is to try to replicate this PyTorch architecture, but the underlying computation is all based on text, based on LLM. And we have the most fuzzy ones, right? Like just like ChatGPT, most creative. I think it's very interesting to see what kind of those modes of computation would prevail in what kind of scenarios. Some other points I would like to bring. So I think the difference between AI software and traditional software, the first is the difference in marginal cost. I think in traditional software, like the usage increase, the cost is a sublinear function of usage, right? Like I can buy a $100 server and it can serve, I serve 100 people, it's the same cost. 1,000 people is the same cost. 10,000 maybe the same cost. So it's like maybe a little bit more expensive, but not that much. But for LLM, like I call one time GPT-4, it can be a 10 cents, 2 times 20 cents. It's a linear function. So actually we are working with many application clients and they are much, much more cost sensitive than they are with, let's say, AWS or traditional cloud software because it's the marginal cost of using AI is so high. And another thing I would like to mention is I think we need to think about to what extent AI applications can have network effect as enjoyed by traditional, let's say, social media, right? Because let's say in Google or Facebook, their recommendation engine can be better and better if more people are using it, if there's more data on the platform. However, for someone using OpenAI API, it's very hard for you to use your own data to improve the performance of the AI API you're calling, right? So what would be the moat in the long term for AI application companies? I think this is a task that every application company needs to figure out. Yeah.
I want to double click on the cost thing because yeah, the linear relationship is worrisome. And I heard Jay, you mentioned economy of scale. So you must have done something to reduce the cost to maybe try to bend the curve to sublinear. And Yangqing, you are an infra company, so you must have a lot of experiences in optimizing. So any insights on how to get the cost to sublinear relationship?
So from our usage, the way to look at building the infra or optimizing the cost is like basically the same as the company Tesla. So they started out by building a car that sells for $550,000, Model S. I think it's more than that. It's 100,000. And then they started build Model 3, which is relatively high. They started sell the dual motor version. And then they started to sell a more basic version and drive the cost down. So it's not that they are giving worse and worse cars or simpler cars, but they also, during their production, they optimized all of their techniques, optimize their supply chain, and the cost goes down. So it's the same as when you build a AI GC related product. In the beginning, you may have a very expensive cost structure. Your usage is low, and OpenAI don't give you discounts. And the more you use it, you start to get good deals from vendors such as OpenAI. You get counter offers from Google, Gemini, and you also start to optimize your clusters. You optimize the usage of your GPUs. And all these things come up together. You can project maybe an 80% saving on your COGS overall. So you need to project your pricing to be so that after you have a saving of 80%, you make a reasonable profit. So in the beginning, then you probably are operating at loss. But as long as you put engineering effort into optimization, you will get much better COGS.
Can I ask a question? So from the 80% cost reduction, what are the percentages that's from negotiating with AI providers like OpenAI? What's the percentage that's from negotiating with a traditional like AWS or GCP?
So OpenAI has this product called provisioned throughput, which you commit to a certain number of tokens per minute for 3 months or 1 month. They give you a discount on the cost, which is roughly it depends on how much, but can range from 5% to up to 50%. And traditional cloud providers, they usually offer, if you are using on-demand like-ish instances, they typically can go down by 70%. If you are using these super cheap on spot instances, you probably still can squeeze an extra 20% out if you sign up on some of their commitment program. So, and then on top of that, you have cluster optimizations, you have algorithm optimizations. In my case, I hired a superstar in audio video engineering, and he wrote a code to replace my gigantic FFmpeg code, and saved 60 to 80% during the rendering pipeline. So they are all huge savings.
I have to do a plugin here. OpusClip recently signed with Static to be our enterprise user. So use Static extensively. Does A/B testing help?
I'm actually prepared to answer that during the QA part. Yeah, yeah, I can give more detailed answer when we talk about that.
Let's save to the QA. Yeah, Yangqing?
I'm actually not particularly worried about cost. The reason is simple. Supply chain is so from, and there's all kinds of existing knowledge that does it. And we're actually chatting just now, right, about this. There's one simple rule in supply chain that applies in AI as well, which is predictability is rewarded with a lower price. Right. Now let me take all those kind of crazy GPU optimizations, CUDA kernels and things like that. Those are crazy. Let me just throw it out, right? Let's make coffee an example, right? You walk into Starbucks, you want to get a latte randomly, right? What do you get? $5, right? Or something like that, about that price. Now, in other cases, you walk into Starbucks, so it's like, I want 100 cups of latte right now. What will happen? $5. Still the same price, but you'll suffer. And the bartender, or whatever the person is called, they will suffer as well, because you have to wait for a long time for that 100 cups to come, right? But if you tell Starbucks, for the next whole year, every day in the morning, I'm basically running the company, we have 100 people, every morning at 9 a.m., I'm going to be asking for 100 cups of coffee delivered to my front desk. What price you'll be getting? You'll be getting a very good discount. And delivery time is good, right? Because you are actually doing a very good predictability in supply chain. This whole thing happens all the time, and then, like basically for retail, the price is always higher, and then if you go to Costco, or basically if you have bulk purchases and things like that, at a predictable rate, you're getting a discount. Today, a lot of these AI applications are just starting, and basically we're just the on-demand, the Starbucks purchase concentration, right? Or in some cases, because people are not really predicting the usage, then sometimes there's 100-cup Starbucks kind of situation, which makes everyone's life miserable, right? But I mean, like you just mentioned, right? As we are seeing a more mature adoption of the technology, adoption of the product, and as we are having a more regular traffic, then the conventional wisdom of supply chain just kicks in, and I think prices are going to be significantly dropping down. And plugging in one unpaid advertisement for Martian, right? So what Martian does is a very simple logic. Correct me if I'm wrong. There's all kinds of retail traffic, people who are spuriously using all those like LLM, like APIs and things like that. Martian is like, well, guys, just don't go to individual places, just come to me, right? And then Martian does exactly one thing, which is they converted retail traffic into bulk purchase, which gives us a better predictability in the supply chain. And so we, Lepton.ai, for example, we are bulk providers, right? We're bulk providers of APIs, and then basically if people come in and basically say like just they want to do retail, then of course there's a price. But if, let's say, hopefully down the road, Martian, I'm actually starting to talk about contracts. If Martian basically says, hey, I have this predictable traffic, right? Could you give me a discount? You know, Marriott down the road actually gives Booking.com 10% commission because they aggregate traffic and they are doing predictability, right? All those kind of things start kicking in, and it made, for all kinds of industries, we already made supply chain extremely efficient. We're just not there yet, application-wise and infra-wise for AI, but it's not a very difficult thing. I think it's something that will happen and is happening, right? And I think that's why I don't really worry about cost.
Just to add a point to Yangqing, I think, yes, aggregating retail demand is one big value prop we have. But we have another smart routing logic that also does a cost reduction logic, right? So let's say we are building like a math GPT. So 90% of the math problems asked on the app is very simple, right? It can be answered by GPT-3.5. And 10% are very hard. You must use GPT-4 to answer it. And to ensure user experience, people usually just use GPT-4 to serve every client, which is very, very expensive, right? GPT-4 is 30 times more expensive than GPT-3.5 Turbo. So what we do is that for each new prompt, we will automatically recognize whether it's a hard problem or easy problem. For easy problem, we go to GPT-3.5 Turbo. For hard problems, we go to GPT-4. And due to the 30x cost difference, so we can like save like 85% of the cost. So that's another way Martian can also help with cost reduction. But yeah, retail traffic aggregation is definitely one of them.
Yeah, I would like to echo that mainly because these kind of things happen in conventional supply chain as well. If we're a little bit sick, you don't go to specialists in like say Stanford Hospital immediately, right? Because those are terribly expensive for the doctor and for us as well. But family doctor. Family doctor is what are they doing? They are doing initial analysis like Martian does, plus routing. They route you to a specialist if needed, or they basically say, well, take a pill like aspirin and be done with it, right? Those kind of things are like conventional wisdom in supply chains, and they're actually gonna be like doing really well in AI as well.
Nice. I like the analogy because we just had a conversation with Howie before this panel that we often see history repeat itself. Yeah, and actually, it's time to move on to the next topic about history repeating itself, and I would like to start with Howie. Is generative AI going to be centralized or decentralized? Because, like we mentioned, PC actually started with IBM being centralized and then became decentralized. Then cloud is becoming centralized. How do you see GenAI is gonna be?
Yeah, I think the context just a little bit more was about, in general, computation history in the last 50, 60 years. We went from IBM mainframe to PC, client server, and then to the cloud. In many ways, it's a pendulum swing from centralized architecture to distributed, and then back to centralized in the cloud days. When IBM, in the IBM mainframe days, and then Bill Gates said in the 70s that I wanted to bring PC to every house, and then IBM guys laughed at him. So, but what happened, 56 years later is essentially we went back to the IBM mainframe. We have three mainframes, AWS, Azure, and then GCP. So we essentially went back. So it's unclear who's going to laugh at the latest. But I think what we discussed was it's going to be a pendulum back and forth. coming back to the Gen AI, this is a debate for a while. That is that well, what's the model, right? Is that if you ask Sam Altman, his argument is, look, you guys don't need to fool around. Just use OpenAI API, do some fine tuning, prompt engineering, be done with it. There's no reason for you to have your own model because whatever our model is going to be a lot more capable, a lot better, anyways. I think that's in many cases that's probably true, but in many other cases that's going to be completely untrue, right? Because there's no way I'm going to, for some customer, there's no way I'm going to give you the data. So for that reason, I need to have my own model, and then. But in the context of the history repeats itself, I feel like OpenAI is like the mainframe, right? There will be it will be distributed, but it will be back and forth. What happens every time when history repeats itself is always where's the innovation bottleneck? That's real. That's the real gist. So think about why IBM mainframe went to the PC architecture, right? That's because there's not much interesting going on with IBM mainframe. It's the boring. Usability is so horrible. So people wanted to have my own way of doing things. So a lot more innovations, but then too much innovation. That's a management hell, and then we went back to the centralized. So I think as soon as someone is dominating, monopolizing things, it's a human nature. It's innovation will happen popped up somewhere else, right? So my view is there will be a lot of the model running on the edge or on the equivalent of the mobile or the PC end. That's just because OpenAI is not going to allow so many different use cases, so many different features, and then it will enable that. But at some point we'll realize, why do we manage so many models? I mean, it's crazy. So we will go back to the centralized model. So that's the context Eugene and I were discussing. If he was asking, is that a centralized? I think we are in the centralized model predominantly, but we are kind of we are going to enable a lot more decentralized or distributed models. But at some point, right, it doesn't make sense for each of us to develop our own model. So it will go back, equivalent to the cloud days. It will come, but it's not there. So we're more moving towards the other direction side. It will take a few years for us to realize that doesn't make any sense. But that will be a few years from now.
Yeah, in terms of centralization and decentralization, I'll probably skip the technology part for another day and basically give you like one example. I think centralization and decentralization could also be discussed on a different dimension. So let's say search, right? Every day we do search and things like that. What is the search engine you use? There's a verb, right? Google becomes a verb. Everyone, I hope, I mean, statistics show that 97 or something like 95% of people, when they're doing search, they use Google, right? Okay, now let me ask you an alternative question, and you'll probably realize that, so you're doing work, right? During our work, we have documentations, we have all kinds of different kind of things. What search engine do you use for that? I will probably say more than half of us are saying, well, it's probably not Google, right? Because Google doesn't have it. If I use Notion, I use Notion as a search, right? If I use Quip, which is, God forbid, that's such an old thing. Quip has a search, although it's bad, right? I mean, everything has a search. And maybe some of your companies, you have a search yourself, right? And there are some suppliers like Elastic and other platforms that are MongoDB that are providing search as well. So very quickly, we find that in the one end, or what we call the 2C world, it's very centralized. It's search, it's Google, right? And in the 2B world, when we're actually dealing with business, it's massively decentralized. We actually don't really have the Google of enterprise search. We have a lot of enterprise search solutions. And I kind of feel that AI, well, let's say chatbot, right, it's going to be similar. In the 2C world, for me, as a consumer, I'm kind of lazy. I don't really want to shop around for multiple choices and things like that. People said ChatGPT is good. Yeah, I'll pay $20 per month, which is 5 cups of Starbucks coffee, which is not too much, right? And I'll just happily use it. And that's why we're seeing a really big convergence onto ChatGPT for us to basically just like do to see conversation bots. In the enterprise world today, things are already happening. There's a huge fight there's a huge fight between ChatGPT or GPT-4 and the cloud and Google's all kinds of different kind of like solutions. And my belief is there's only going to be much more players in this world. Not only these kind of providers, but also models, applications, some things, capabilities built in-house from the enterprises themselves, right? So in the to-be world, things are going to be massively decentralized. Now, plug in a little bit of our advertisement. What we see is basically, we see that the to-be world is going to be decentralized, and as a result, people will be needing tools, right? When every company is actually doing their websites and things like that, well, database, BI, and those kind of things become a thing, and then Databricks, Snowflake, right? All those kind of companies start emerging. What about AI? There's got to be some sort of company that does it, and just to throw away all those kind of details, we strive to be that company to help the decentralized to-be world. Yeah, that's the answer.
Nice. Thank you.
I think the previous two speakers have really great answers. I want to offer the answer from a slightly different perspective. I think from the first principles point of view, right? What determines the end state of the industry is basically only one thing. That is the economy of scale of that business. So why would social media and search engine, two of the biggest industries, are extremely monopolized? Like Google is the only player, like Facebook is the only player. Why? Because that business has huge economy of scale. Because the more users use Google, the better Google search engine is. I was talking to some early team leader at working on Microsoft Bing. Right? He described to the desperation, like they put much more resource into search engine trying to catch up, working on a 724, but they still are not able to catch up to Google. Right? Google and
if you don't mind me chiming in on this one, there's a technical reason behind that. Do you know what is the biggest signal for Google to rank the search results? About 5 years ago, or like when disbelief was what Google Brain was proudly saying Google Brain deep learning is supporting Google search, they said in their post, you can actually search for it, they said AI or deep learning has become the third largest signal, the third most important signal to rank search. They never talk about what is the biggest one. And the biggest one turned out to be human feedbacks. If I search for something and I click something, then it means that other people are more likely to think that that one is important. And because Google is occupying more than 90% of the traffic, no one else is able to compete with it. Because, I mean, why do I think that search result is good? Because the other people think it's good. It's natural. It doesn't even have anything to do with AI. So that's what you mean by benefit of scale.
That's exactly the case. That's a classic definition of economy of scale or network effect, right? And similar with Facebook, with WeChat, with all those social media. And now the question is, to what extent does foundation model LM have this economy of scale? I have to admit, like about 1 year ago, when I first see ChatGPT, I was so scared that OpenAI can be a company that literally take 95% of world GDP, right? Because it seems to be a business with huge economy of scale. You put more data, more compute into one model, and this one model can solve every problem in the world. What's a business with bigger economy of scale? But gradually, when I dig more into the industry and train more myself and serve more clients, I discovered it's actually not the case. Right? I think people are discovering more and more new ways of training model that are way more efficient, and those new techniques are because they are like inspiration based, right? It's not possible for OpenAI to monopolize those new ideas. I think one very good example is Llama 3. I'm sure many of the audience right here have heard about it. We have benchmarked Llama 3 8 billion internally, and it's very good. It's way better than many previous models, which with much larger parameter size, and it's very efficient, right? And it's not being produced by OpenAI. And I think at any time point, the model, the amount of resource you put into training a model is actually not, the economy scale is not that big, right? I put 1 billion into training a model versus I put $2 billion to train a model. The second one is not 2 times smarter, right? It's like a declining marginal return in putting more compute and resource. So I think this is one of the fundamental reasons why I think OpenAI is not going to take over the world, because this business does not have that huge of economy scale. And another reason I think OpenAI is not going to take over the world is AGI will not be built by AGI requires context and specific knowledge to be useful in specific scenarios. And we can think of the smartest model in the world as some genius college graduate, like Einstein in his 18 years old. He's very, very smart. He can pick up things very quickly, but he's not useful to, let's say, work at Google, work at Martian, right? We have so many internal contexts, internal rules, internal subtle, like interpersonal thing management, everything. Like that needs some onboarding process, and it's not possible for OpenAI to acquire that part of the knowledge. So there needs to be, third-party SaaS, third-party, whether 2B or 2C, to modify the general purpose intelligence into domain-specific intelligence that's actually doing the economically useful work. And there's a very good paper written by Berkeley people and Databricks co-founders called compound AI systems, right? That's exactly a thesis. The best results are not delivering by the latest cutting edge, the smartest foundation model, but rather the compound AI systems that agents, RAG, chain of thought, and all those applications that build on top of those. That's how we achieve real AGI, and that process will be decentralized in essence. Yeah.
Jay, do you want to?
Well, it's a long discussion, so I'll keep it short. So it's a related thought about decentralization, which is when you are building a startup, people or VCs will ask you, what's your moat? And how about these big guys will defeat you? These large model companies, they will be so powerful that your application is not going to be useful. This is especially true when Jasper basically died after ChatGPT came out. The thing is, I think when you talk about decentralization, I agree with Jason's topic, which is domain knowledge or context is very important. It could be your moat, at least for you to survive for a while. For example, in our company, how to clip a good video is getting more and more becoming of our moat. And these domain knowledge, they don't appear very apparently on the internet. And they come up with deep knowledge when you build your product, when you interact with your customers, you get your feedback, a lot from A/B testing. And so, yes, we use statistic extensively for A/B testing. So these data become very valuable to your company and win you time to have higher moat. So there is no golden moat you can have. You keep building moat, and people eventually, if you lie down and rest and vest, then you will soon be out competed. So yes, so the domain knowledge is a great thing for you to survive as a startup.
Thank you for the mentioning. I do think A/B testing is about measurement and learning, and that will become a moat. Time flies very fast when we talk about deep technical topics. We are already over time because we want to save some time for audience as well. I actually prepared 6 questions. We just got 2. The rest of the questions are: what are the challenges? What is the TAM, the total addressable market of GenAI? And what role will proprietary data play? And which companies are well positioned to get this proprietary data? And is there any effective tricks in doing GenAI? But I guess because we don't have time, we can save that for other days. If you can interview the guest on our social media, subscribe to Static if you're interested in this kind of topics.
And then also buy the future.
Yes.
BYTE, the future. Do it now.
Yeah. We are going to open to the audience for Q&A. Just raise your hand if you are. Yep.
Thank you for all the speakers' amazing discussion. I can start with a very non-technical question. So in one of Klebiao's video, Howie foresee or forecast the AI wave before it hits the shore. So I'm looking for advice or tools or resources for normal tech workers like me, not to foresee, but how to keep most updated in this AI environment. Thank you.
thought I just give the answer already. I think on the more serious side, that's a very good question. I think this is something Yuzheng and I actually talked offline and online quite a bit. That there is so much noise. I think this is one of the interesting angles. I've actually been thinking about this for quite a few years in the recent past. That did the internet help us to acquire new knowledges or good knowledges or not? In the first 10 years or so, the answer to me was obvious, right? It's so easy to get knowledge. Google gave me access to everything and anything on the planet. In the last few years, I'm not sure about that. I think when I say I'm not sure, I'm not saying myself or Yuzheng, or I'm just saying that in general, the population, did we improve the signal to ratio, signal to noise ratio or not? It's not very clear to me. So the actionable thing for everyone here, including myself, is we need to be sensitive about where to acquire the knowledge, and how to spend time, and then how to think about this, right? So one thing, it could be controversial. So every time I do an interview or not, towards the end of the question is always often about which book do you read and I want to recommend. And also there's also implied theory that the more books you read, the better. I'm not sure about that. I feel like today, I feel like I'd rather read a good book 3 times rather than read 3 books. It's like a training data, right? Is that a lot of data? The more, the better, or you have high quality data? I think Llama 3 has taught, not just Llama 3, but Llama 3 taught us again that the high quality data makes a lot of difference. So I'll close with one thing that Yuzheng and I discussed in a podcast, another podcast, the video interview before that. Whenever he's doing a program or I'm doing a program, I almost feel like I wanted to do something so that people can listen to 10 times and they still feel like they are learning. I think that's probably, the bar is very high. I don't know I can get to that point, but that's almost the bar I wanted to get to. And I almost feel like when we acquire knowledge, on the internet, that's something we should be thoughtful about it. Not just the more the merrier. That's one thing I've been thinking in the last few years. In some ways, internet allow us to acquire knowledge too fast, too easier. Is that really a good thing? So that's a question for all of us to think about. But that's a very good question.
I'd like to basically provide some sort of practical answers. So Twitter for really cool technologies and a little bit of drama, like GOT or Downton Abbey or How I Met Your Mother kind of style. Hacker News for cool technology and nerdy discussions or things like that. LinkedIn for serious business opportunities and stuff like that. And then, of course, really awesome podcasts like these guys, right? I think that's basically what I do for collecting information, because there's just so much information flying around. And then, well, if you find some articles to learn, then pull up Elmo Chat and you can just do summarizations. But normally those websites are actually providing a good coverage. The reason is I think people and platform co-evolve, and for Twitter you just can't post some serious business stuff, but LinkedIn people are always dressing up, polished, and then publish it, right? So those kind of platforms naturally gives you different angles and help you filter through a bunch of information already.
But since you mentioned the Twitter, Andre Karpathy actually made a tweet a few months back, maybe 2 months ago. He said something like a tweet is very much like downloading the file executable on the internet. It's unclear that's a malware or not. That's the very point I was trying to make. But Yangqing said is right in the sense that what kind of information reasonably popular on which website. But my early point is more like, when you acquire the knowledge, you need to be careful, right? Is that a executable, you download it from internet to think about it.
I mean, you have to be outrageous on Twitter to be popular, and that's why Twitter is full of outrageous. I mean, there's one very famous search company CEO who appears to be a big D, but he's popular, right? So that's why, I mean, every platform has biases. I do too. So yeah, right. And I think Howie very nicely pointed out that we should undo the biases while we are actually consuming those information. Sorry for the comment about that CEO. Don't tell him.
Next question.
Yeah. First of all, I want to thank you for all for sharing your expertise and wisdom with us today. And second, I think at this time, like all the companies are trying to find how they can use GenAI to empower the business to like stay relevant in the game. So the setting is like this. You have a company, you have a few pretty good use cases that could leverage LLM. And there's actually like proof of concept, but there's still some gap to really bring it to like real business value. And you're trying to build a team like more horizontally to empower those products. And since LLM is so different from like traditional ML infrastructure, I'm curious to like learn like what do you think is the key components and consideration you think you must get right to make that happen? So I think we mentioned like evaluation, monitoring, cost. Yeah, I just want to hear more about that.
Maybe I can start because I built product that is, so we don't have very deep AI in terms of training large models using tens of thousands of GPUs, but we still use AI to build a useful product. So it's important to understand the real needs of your users and then harness the power of AI for that. I think if you don't understand what problems or what pain points your customer have, it's basically trying to find a nail using a flashy new powerful hammer, which you don't really make any impact. So finding and as a lot of people here are technical background, it's even more important for you to learn about the product sense and to read books like Innovator's Dilemma, Jobs to be Done, that kind of business knowledge. And it will be really essential for technical people to understand the customers and find opportunities for building a product. Then AI comes into hand to you as a new technology to build a shiny new hammer. And the important thing is find the nails that hasn't been hit by other old bad hammers.
To add upon Jay's answer, I think from a more practical standpoint, evaluation is probably the first and foremost and most important thing in building like GenAI use cases, right? Because we are collaborating with many application side companies. I see so many companies, they don't even understand how do they evaluate their LLM use case, and then just jump directly into trying all those fancy techniques. I think, and in evaluation in the GenAI age is very, very difficult, right? Like basically, it's how we evaluate humans. It's similar to how we evaluate LLMs, right? But we need a consistent, robust metric to see whether we are improving our performance or deteriorating our performance to build upon from the starting point. I think less people realize the importance of evaluation than what should be optimally be the case. Yeah.
Do you have any tools or vendors you would recommend? You feel like this company doing some of the evaluation much better, provide an evaluation solution much better? I think it is a framework. I think evaluation is a very long pipeline, right? I think static is one component. Clearly, that's a very good tool. Anything else, on this, in this pipeline? I'm just curious. What do you see?
Yeah, there's no simple answer due to the innate complexity of LLMs. But so I think the way to evaluate range from more static to more dynamic ones. On the most static side, we have evaluation benchmarks like MMLU, which is literally to let LLMs do multiple choice questions, right? Those are very straightforward, very easy to evaluate. And slightly more complex and more nuanced, we have things like GSM-8K, where we ask LLM to solve math problems. But the solution for a math problem, sometimes it's not a single number where you can parse and query. It's like a whole reasoning process. So we need some other humans or other AI systems to evaluate that. And similar, we have like how to evaluate the code generation ability of LLMs. You need to actually execute the code, right? I think the most nuanced scenario is like how do we evaluate ChatGPT, or how do we evaluate general chatbot, similar to how do we evaluate like humans, right? So at Martian, we have an entire suite of toolings, a framework to do those kind of complex evaluation. That's basically a combination of human annotation, machine-assisted annotation, and purely automated evaluation. So that's a fairly complex topic. Yeah.
We do have a extensive need and experience in handling fuzzy output. So it's very interesting that, or intuitive for us to use AI to evaluate AI. So what we do is, so we outpace our competitors in terms of the clips generated, the quality of the clips, how interesting are they? So it's not because we have really magical prompts. We use GPT 3.5, which is a pretty stupid model, and it's cheap. It's almost like 95% off based on GPT-4. So the way we do is we have many prompts that try to clip a video, that just not one, but at least 4. So they have different ways to do it. And they try really hard. And every video, we probably have like 100 clips candidates. And how do we pick the best? Is we use another set of prompts. This set of prompt is evaluating the quality of these clips with multiple dimensions. For example, are they interesting? Is it a story? Does it start with a very intriguing hook? Does it have defect like sudden ending? Is it a sponsor message? These kind of scoring. And we give these scoring a combination and finally combine them into a final score. And then we rank the candidates. We only pick the 20%. So in any industrial process, for example, if you are working on a farm, you have a lot of produce like strawberries. When you sell it, you sell the good ones to Safeway, and then you throw away some of the bad ones, and the mediocre ones you probably send to a worse tier groceries. So it's the same when you are building a product, you want your system try harder, and you want to get the good ones. And one way to do it is using AI to evaluate. Well, there is a caveat there, though. Some AIs don't catch the trick. So I have an example on my Twitter, which is at J of Opus. That's my only interesting post I have. It's an AI generated image of some craftsman, and the person's head and the neck are obviously disconnected. You can see from the video. You can see from the image. But I asked this image with with GPT-4, with Gemini, with Anthropic, and all of them say, "Oh, it's a very okay image. It makes very much sense. Nothing is weird." And even after you prompt them, is there something wrong with their head and their neck? And the AI will say it's very normal. So you can 100% rely on this, but it's helpful framework to try harder and then evaluate using AI and then get the best results.
Nice. I love keep hearing those answers, but unfortunately, time is the limited resource here. We have one last question.
So thank you for offering me this opportunity. When I think my question is a little bit technical, I think many audience with technical background might be interested. The thing is, I'm recently doing research with professor and his collaborative team in AWS on the reliability and observability for machine learning system. And this, my question is kind of related to Howie is sharing about the QA part. The QA part. For example, now we know that in order to train a model efficiency, we have to train it in distributed strategies, like using the tensor parallelism or pipeline parallelism. But this will have a backfire, which, like, given a fixed input, like a fixed data and a fixed parameter or fixed weight of the model, but with using this distribute strategy, the output of the model will be huge different. And it's hard for the developers to debug within a few days. And we now heard many complaints from Amazon's developers. They said we cannot locate this failure because the numeric difference will accumulate. But during this process, there is no such very efficient way to discover it. So my question is about how to improve the reliability and observability, especially in distributed system training. Yeah. Thank you so much.
Yeah, oh man, I have so much to say about this. Yeah, I'm already starting to run, basically. First of all, this is not a new problem. Starting from the 1970s, there's the scientific computation, or HPC world, that already knows that when you are actually doing numerical computation, things are just not possible to reproduce, right?
Yeah, that's right.
And I think right now, basically, I mean, the AI community are a little bit, me included, are a little bit of a spoiled child, and are not willing to look at existing solutions for that. There's one existing solution, which is numerical stability, right? If you add 4 float numbers together, if you do 1, 2, 3, 4, or 4, 3, 2, 1, things are different. But you can statistically measure the stability, which is a very important thing in numerical computation, right? If you do exponent of something, then you want to make sure that that something is not outrageously large. If you do x62, you're going to be anyway, right? So all those kind of things are actually already there. So I would basically argue that the solutions there, we just need to basically employ numerical stability into it. That's one part. The second thing that you mentioned is basically about interpretability, right? That's also something that's really kind of like outrageously academic, I would say. People don't care about interpretability. And let me give you one example, right? Okay, so we're all computer vision or things like that. Explain to me what a cat is in pixels, right? We're forcing computers to basically say we need to have an interpretable computer vision system that classifies a cat. Now it's like, well, interpret our own brain. You'll basically say, oh yeah, a cat has, like pointy ears. I was like, well, what is pointy, right? What is an ear? There are something that is naturally complex and uninterpretable. And I think that is fine in many cases. And I mean, if you think about it, you're driving the car back home today, right? Now, we don't know if that car is, might break down or not, right? Maybe there's just a fatigue in the middleware and it breaks down, right? There are things that are not interpretable. It's just, as long as we have a more statistically safe way to put things in a safe box, then it's fine. And I think this is kind of like one fundamental, looping back to the very first question, what is changing in the era of AI versus not AI? AI is naturally just statistical. It's not like if you call a function, it does a defined API, a fixed input, fixed output. No longer. This world has changed. And we just need to accept it and then build security fences around those kind of things so that statistically, or basically after these bounds, things are working properly.
Okay, thank you so much.
Sorry, I ranted too much.
Oh no, I think with that it's a very nice ending, and I like the line that the world has changed. We just need to accept it. So we have a room until 9 p.m. Feel free to network, social after the talk. With that, let's give it up for our speakers. All right.
Thank you, everyone.
Thank you. Thank you.